So the next topic is Ohm's law. So is there a relationship between the potential difference across the conductor and the current through it? So let us recall with an activity, and also we can conclude. Okay. So see the figure. Okay. See the above figure. So set up a circuit like this, which is consisting of nichrome wire X by of length L, let us say as 0.5 meter, and a meter, a voltmeter, and a 4 cells of 1.5 volt each. And nichrome is an alloy of nickel, chromium, manganese, and iron metals. First, use only one cell as the source in the circuit. Note the reading in the ammeter I for the current and the reading of the voltmeter V for the potential difference across the nichrome wire X by in the circuit. So tabulate them in the table. Next, connect two cells in a circuit and note the respective readings of the ammeter and voltmeter for the values of current through the nichrome wire and the potential difference across the nichrome wire. So repeat the above steps using 3 cells and then 4 cells in a circuit separately. Calculate the ratio of V to I for each pair of potential difference V and current I. So you would have noticed that this V by I is always a constant. In this activity, you will find approximately the same value for V by I. Thus, V by I graph is a straight line that passes through the origin of the graph. V by I is a constant ratio. It is a German physicist Georg Simon Ohm found out the relationship between the current and flowing in a metallic wire and the potential difference across its terminals. The potential difference V across the terminals of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided by the temperature remains the same. This is called as Ohm's law. In simple words, Ohm's law states that at constant temperature, potential difference is directly proportional to the current through the conductor. I already told I would have given the difference between the current and the voltage. Okay, so I'll tell about the difference between the voltage and current first of all. So voltage is nothing but how fast or slow an electron moves, and current is simply a flow of electrons. So when the electrons flow faster, we call it as high voltage, and if the electron move slower, we call that as low voltage. Okay, so in this case, V, as I told, is directly proportional to I. So V by I is equal to constant, and this constant is denoted by the letter R. R is a constant for metallic wire at a given temperature, and it is called resistance. So it is a property of a conductor to resist the flow of charges through it. And the SI unit of voltage is ohm, and SI unit of resistance is ohm, and it is denoted by the Greek letter ohm. So according to the Ohm's law, V is equal to IR, or R is equal to V by I, or I is equal to V by R. So depending on the sum, we can interchange the formulas from the derivation of V is equal to IR. So it is obvious that the current flowing through the resistor is inversely proportional to its resistance from the equation I is equal to V by R. So what if the resistance is doubled? The answer is, if the resistance is doubled, the current gets halved. In many practical cases, it is necessary to increase or decrease the current in an electric circuit. A component used to regulate current without changing the voltage source is called variable resistant or a rheostat. In an electric circuit, a device called rheostat is often used to change the resistance in a circuit without changing its voltage. Okay, so this is all about Ohm's law. So thus we can conclude that Ohm's law states that at constant temperature, potential difference V is directly proportional to the current. So what is the meaning of directly proportional? If one quantity rises, the other quantity also rises. If the voltage is more, so what will happen to the current? High voltage results in high current. low voltage results in low current. So we can conclude that V is directly proportional to I.